This is the conclusion of our class. I would like to start with the state space search. The idea of the state space search is we have to convert any problems into the state. So in the state, you can think like you have the format or some kinds of representation. And for example, this one is like the state of the n queen one, that you represent the state in the real world into the numbers like this. This is a row of the queens in each column. So this is the first one, second one, third one, and fourth one. So uh, the first important things is you have to represent the status of the problems into the state, and then you can change the state by some operations to generate all successes that you can have. For example, you can move queen up and down, and if you move queen up and down, it will be changed into this state. Okay, so after you know that you have the state, you have to put the state into a list called the fringe. The fringe is like a linked list in any other languages, and in Python it is a list. In the fringe, it will store the node, and the node will store the state and other informations. For example, or maybe you have to store the cost. G is the cost from start to end to this state. It may store the parent node. Where is the parent node? Okay, so this is the kind of the nodes that we can have. Okay, and we will work with fringe to store like to generate, to move it to the first search, breadth search, or iterative deepening search. For each algorithm, you can watch in the videos in more detail again. For the depth first search, actually, there are four steps in the loop. That the first step is you have to remove the font. Oh, sorry. The first step is you have to check that if the fringe is empty or not. If the fringe is empty, it will be like the fail one. This is a fail state that you cannot find the solution. Okay, that is the first step. Check if the fringe is empty. If it's empty, okay, it's fail. No answer. Next, you have to remove front. And the third step is check that if the front is gold or not. If the front is gold, you can return the solution. If not, you can go to step 4. That is to generate all successes and then put it back to the fringe. For the depth first search, you have to put it in front of the fringe. Depth first search, you have to append at the end of the fringe. And iterative deepening search, you have to use the depth first search, but try to increase the level of the depth of the limited level, the maximum depth that you allow this algorithm to search for. So this is the blind search. We call it the blind one, or the uninformed. The meaning of uninformed or the blind search is it uses information, the past information, no prediction, no forecast, no approximation. Okay, and if you have something like the informed search, if you use the approximation of n to goal, the cost from the current to goal. This is the approximation of n to goal. It will be the informed search. This one we call it the heuristic function. Okay, and we use it in many forms. We will sort everything in the fringe. We not put it in front or at front or back. No, we will sort it by Fn or evaluation function. You can think that this one is evaluation function, and this is the evaluation function that for the greedy search Fn is Hn, sort by Hn only, and this one is greedy. This one is A star. Fn is Gn plus Hn. This is a chord from start to end. This is the approximation from end to goal. So Fn is the approximation from start to goal, but it will it will it must pass n. So and this is like the idea. And for A star, it will give you the optimal solution. Optimal solution if Hn is an admissible heuristic. The heuristic that never overestimate the cost. So that's all for the gradient A star. And I want to go back to depth first and breadth first. The problem of depth first search is the time, because it may be like you have to go by b power m to grow the tree by maximum depth, that is m, and the branching factor is b, and the branching factor is breadth first search is the problem is the space that you have to store big O b power d. Okay, that's all. This one is like the problem that even the simple as 8 puzzle, it cannot be solved by the uninformed search. Okay, but if you use the informed, use A star, it will give you the optimal solution. So and then I'll talk about the GA hill climbing and simulated annealing. This group is we need only the solution. We don't need the step to the first one is you must go up, down, left, right. No, just we need the final state that meet our constraint. Okay, this is the solution. Okay, so for hill climbing, you have to store it like you have the current state, and you try to improve this one by any function, and then among all children you have to choose the best one. If the best is better than or equal same as the parent one, you can set it as the parent and generate all children again, and we will never go back to any other node in the previous level. So this one is greedy one. But the problem is sometimes or in some kind of problems. For example, if our state has only one value, that is the x value, if the start state is here and you have to go left or right. Of course, you have two children, left or right, right? And then you have to go left because left is higher, better. And you have to go left, left, and again. Once you go left and left, this one, you will not have the children that's better than this, right? This one is is called local maximum. Okay, so we will solve this one by this simulated annealing. The idea of simulated annealing will control the search by the probability. Okay, this one is the difference between next and current. The idea of simulated annealing is different. Among all children, will randomly choose one of the children, and then if this one is better, use this as the current and then go next. If not, you have to check whether this is the probability to go. Okay, this is different between next and current. Okay, if next is less than current, it will be this is next is less than. Next is less than, it means that this one is negative one. So if this is negative, you have to change it to this. This is the probability. So that's all. That's all. So this is the probability of these values. Okay. So if this one is like the difference is very like very high, next worse is worse than, but delta E is very high, so this one is will be very low, right? Because this one is very high, this value is high, so the probability will be low. So in the case of delta E that is high, the probability will be low. So the chance that you have to jump from the cliff is very low. Okay, and T is the temperature. We need something like this. This is the temperature, this is the time. So when the time passes, the temperature will decrease, but we need it to be decreased like very slowly decrease. Okay, because at the part that the temperature is still high, if temperature is high, probability also high. This is high, this is low, this is low, so this is high. Okay, so this is a simulated annealing. And GA1, the idea of GA is you have the state. You must have at least two parents in each generation. You can mutate, choose one of them and change the values up, down, or randomly change it. This one is mutation, and you can have one new state. This one also you can change the values of state. So there are two new from the mutation. And the crossover, you can choose any. This one or this one or this one. This is the point that you can cross them. So you have another two population. Okay, so now we have 6 of them. So you have to provide a policy of choosing the population to go through the next generation. Most of them is like the fittest survive. You have to check the desirability via the fitness function of the state. Okay, and you will have two new states, two population that go through the next generation, and you do it again, mutation crossover and use the selection to choose 2 of them or 4 of them. But many people not only choose the fittest, but the one that is to try to maintain the diversity. Why? Because if the first part of the population are same, if you cross it, so nothing new happen, right? Right. So you have to think about diversity also. This one is the idea of the GA. Okay. Uh, and actually, in our AI, normally I will use the normally we will use machine learning, but all of you already passed the MLDL, so I skip that part. But what I want you to know is we will use the um, reinforcement learning. Okay, but I'd like to tell you that you must know the uh, machine learning algorithm also, but you already know from MLDL, so I skip that one. Okay, okay, so uh, I add the reinforcement learning and game playing. Okay, the idea of game playing is you have the state, but we will we will use some measurement, some utility function, some function to evaluate uh, the status. For the game playing, we cannot we cannot control all levels of the search. For example, in this level, if the function that you use to measure the status of the state, if the value is higher, it means that you are like you have higher advantage over your opponent. So you have to choose the maximum one, right? But for your opponent, he or she will use the, of course, if your opponent is the optimal opponent, he or she will use the lowest one. So you cannot control all of them. So the idea is you have to use the depth first search. You have to use the depth first search. If you choose this way, your opponent are, can have three options, and from these three options, sorry, your opponent, this is your choice, and for each choice, your opponent will choose the lowest one for him or her, and again and again. So you have to compare all of this and choose the maximum one. For example, is this 3 to 8? So you have to choose 8, and you have to search under this node again. And for example, if this is 3 and 2, your opponent will choose 2. So if you choose this part, you will get 2 with the optimal opponent. Okay, and you have to search it again and search it again. And for example, this is 2, 3, 4. So you have to choose 4. If you go this way, you can get 4. Okay, that's all for the game playing. But we have the alpha and beta cut that can prune the tree. Okay, this is alpha and beta cut. The detail of the alpha and beta cut is in the video, so you can watch them. And the last one is the reinforcement learning. Reinforcement learning. So the idea of reinforcement learning is you have the state and action in the table called Q table. For each state, you have many actions, but for each action, you must have the score, and it can be updated. It can be updated. For example, if you are at state S1, you apply A S1, go to S2, and if you apply A2, you go to S3, and in some case, in some S3, you have immediate reward. So you have to update the Q value that you get the immediate reward. Maybe it will be negative also, like the punishment. So this one is like a very interesting idea of learning, because we don't have the solution at each state, but along the way that your agent go through the state. For example, this one has the reward again. So uh, this action should be like the should be get should get the reward. Okay, so the Q values of this action should be high. Okay, so this one is the idea of the reinforcement learning. And I talk about OpenAI and the gym library. Please, this is the gym library. So please try to play with it. I think it's a great one. So you can enjoy OpenAI and gym. There are like Atari one, the game that you can let the agent walk through the games and try to play, try to add that if the status of the game is like this. For example, if it is at state 101, which action that you should do? Go up, oh sorry, go left, go right, or stall, hold still. Okay, nothing to do, like this. Okay, because for example, if you have the game like the Galaxy One, and you have your spaceship here, and this is your enemy, for example, and there are some uh, bullets from your enemy. So you have to represent this into the state. And action, there are just only 3 actions: A1, A2, and A3. That's all. Go left, go right, or stay still. Okay, that's all. Okay, so maybe you can choose something like the closest bullet. Where is the closest bullet, and the distance to the left, to the right. You have to represent everything in your state. And if you can represent it and you let your agent play with this, you will know that, okay, if this is the state, which action you should do. That's all for our first part of the AI, and I hope that you can transfer our codes to your robot after the midterm. Okay, so I hope you enjoy it. See you guys.